Hey guys, so welcome back. We're going to be doing our factoring review today. So we're going to be talking about factored form, which I know we went over quite a bit last semester. We're going to bring it back and review it so it's fresh in our minds. We're going to combine it with solving, which is what we've been talking about in our last unit. So first, let's look at our factored form. So here we have our x minus n times x minus n. So our factored form right here. This is going to highlight our x-intercepts, going back to the key feature that those highlight. So this highlights our x-intercepts. We can pull out our x-intercepts from here. Remember, we're going to change the sign of whatever this number is. So here we have minus m, so it's a negative m. So we're going to pull it out and make it positive. So our first one is going to be m comma 0. Notice we have the number is first and then 0 for our y value. It's going to put it on our x-intercept. So my second one, I'm going to do the same thing with this negative n. I'm going to pull it out, change the sign. We get n comma 0. So this should be a review over our x-intercepts, how to find them from factored form. So now we're going to talk about how are we going to get into factored form. First things first, we need to make sure our equation is set equal to 0. Our equation has to be set equal to 0 for us to start this process. From here, if we're in standard form, we need to find our values of a, b, and c. If we remember, if we were looking at a standard form equation, so our standard form equation, if we had something like x squared plus 6x plus 5 equals 0, we would identify our a, b, and c values as our coefficients right here. So this would be my a value. What's next to my x squared or my variable squared? This would be my b value, and this would be my c value. So next thing, we're going to list all of the factor pairs of C. So we're going to talk about factor pairs. Our factor pairs are our numbers that multiply to our C value. So here in this case, the only numbers that multiply to 5 would be 1 and 5. So this would be our factor pair. It would be both of these numbers. We're also going to have to consider negatives if B or C are negative. So consider negatives. This would mean that if this C was negative, maybe 1 is negative, maybe 5 is negative. We would have to figure that out based on which of these is negative. Next thing that we're going to do is to figure out which factors we're going to end up using. We're going to add each factor pair together until one set equals B. So if you look up here, we only have one factor pair, but we can see that 1 plus 5 is equal to 6, our b value right here. So the last thing that we're going to do is we're going to place this factored pair into factored form. So we're just going to rewrite what our factored form looks like. I want to make a point to make sure that we know that this negative is not always going to be here. Whatever your factor is, if it's positive or if it's negative, the sign stays with it. So I could have, if my factor pair was 1 and 5, I would have x plus 1 and x plus 5. So just make sure that we're not always keeping that negative here. All right, now we're going to take our steps and we're going to rewrite into factored form. So up here, let's look and see our step 1 is make sure the equation is set equal to 0. Here it's not equal to 0, so we have to change that. We're going to subtract 5 from both sides to make sure that we're going to get 0 over here. So I can rewrite for step 1. We have x squared plus 4x. I'm going to do 9 minus 5 gives me 4. And now our equation is set equal to 0. These cancel out. My 5's do. So step 1, we're good. Our equation is set equal to 0. Now we look at this and we see what form we're in. We're in standard form, so we're going to be looking for our values of A, B, and C. So they're my coefficients. So right here, if there's nothing next to it, we can imagine that we have an imaginary 1 right here. So it may not be written. We have an imaginary 1 right here. So my A value is going to be 1. My B value is going to end up being 4. My C value is 4. So I just found these from my standard form. All right, the next thing that we have to do is we're going to list our factor pairs of C. So we're going to look and see my factor pairs, what multiplies to 4. So we can do 1 times 4. That multiplies to 4. We can also do 2 times 2. Those also multiply to 4. I don't have any other factor pairs, so I'm done with step 3. Now step 4 is going to help us decide which factor pair are we going to use. So let's see if any of them add up to our b value, add up to 4. So we do 1 plus 4 equals 5. So we're not going to be using these. So we can say we're not going to use those. Let's look at 2 plus 2. That does equal 4. So that's how we know we're going to use these factors. We're going to use 2 and 2. All right, our last step is we're going to place this factored pair into factored form. So remember I said we're going to keep our signs. So let's look up here. We're going to do x. We have a positive 2 and a positive 2. So x plus 2 and x plus 2. Now we need to make sure that we're keeping this equal to 0 because it is still an equation. An equation always has to be equal to something. So here we have equal to 0, so we're going to keep that equal to 0. If we look at this, it looks just like our factored form, so we're done for now. It is in factored form. All right, let's talk about this one right here. We have x plus 3 all squared. So this is going to be really nice for us because we know when we see something squared, it's going to be written as itself times itself. So I can take this expression and I can expand it. Know that x plus 3 squared is the same thing as x plus 3 times x plus 3. We still have an equation, so it's going to be equal to 0. So this one worked out really nice for us. We didn't have to do too much, and we're already in factored form. So the main focus of today is being able to combine this process of factoring and solving. So let's talk about solving real quick. Just as a quick refresher, this is in our blue solving quadratics chart as well if we forget it. But to solve equations in factored form, we use the zero product property. So when we talk about the zero product property, we can set each of our factors equal to 0. So the reason we can do this is because we know 0 is going to be our answer. So anything times 0 gives us 0. It's the only way we're going to get 0 over here when we're multiplying. So that tells us that one of these at least has to be equal to 0. So let's look up here and let's finish solving this one so we have an example. So my zero product property says I can break these up into two equations. I have x plus 2 equals 0 and x plus 2 equals 0. We might notice that these are the same, so we can just solve one of them and we'll be good. So to get x by itself, I'm going to subtract 2 from both sides. So this cancels out here. We get x by itself. X equals -2. Very important. Once we're here, yes, this is correct, but this highlights our x-intercepts. So what we want to do is we want to write these as an ordered pair. So we're going to take our -2, we're going to write it as an x-intercept. So we're going to write -2, 0. So I solved for x and I wrote my final solution as an x-intercept. So here I factored and I solved and now I'm done. Let's do the same thing over here and then we'll talk about solutions real quick. So from here, my zero product property, I can break these both up. I have x plus 3 equals 0. And then I also have x plus 3 equals 0. Once again, they're the same, so I can just solve one of them. That's not always going to happen, but it just happened here for us. So I have these cancel out, and I end up getting x equals -3. Just like over here, we want to write an ordered pair. So I'm going to come over here and write -3, 0. All right, so now we have factored and we have solved. We're going to talk about our solutions real quick, just as a quick refresher, so we have them on this paper with us, and then we'll be done. So first, let's talk about two real solutions. I'm going to have two real solutions when my factors look different. So my factors are different. So this means if I had something that looked like x plus 2 and x minus 3. X plus 2 and x minus 3 are different, so I have two real solutions. Now if I just had one real solution, we might notice up here in our examples, we only ended up getting one real solution. That's because the factors were either squared or they repeated. So we can say the factors are squared, or the factors repeat. We might see it both ways. We could see it squared, or we could see it as itself times itself. They're the same thing, they're equivalent, so we're good here. So if we want a little example, we can say x plus 3 squared equals 0, or we can talk about what if we had x minus 1 times x minus 1. These both would give us one real solution. All right, the last thing we'll talk about is if we have complex solutions. So if we have complex solutions, I know we haven't seen it very much, but our factors will contain I. So if we have an I in our factors, then that means we're going to have imaginary solutions, complex solutions. So if I had x plus 2i times x minus 3i, these would give me complex solutions because I would solve for x. All right, so that is the end of our Edpuzzle video for today. We went over factoring, we did a little bit of a review on how to factor, we combined factoring and solving, and we also refreshed on our solutions.